All right, I hope you're in the right place. This is a Pre-Algebra Lesson 2.1, Properties of Addition, and so we are just getting ready to start Chapter 2. So this is Pre-Algebra Chapter 2 and Lesson 2.1, Properties of Addition. And we're going to learn some properties. These properties will come up in Pre-Algebra. They'll come up again in Algebra. They'll come up in Geometry, most definitely, and then again in Algebra 2. All right, so the first one is the closure property. C-L-O-S-U-R-E, closure property, the closure property. What does the closure property say? Basically, it says this, and I'm going to write this in red. All solutions, and I'll finish in blue, are part of the same set. Are part of the same set. All solutions are part of the same set. Okay, so what are we talking about? We're talking about our number sets. So a real quick review of our number sets. The natural numbers, and that's capital N is the symbol for the natural numbers. We got to use a brace for this set. It's the numbers 1, 2, 3, and up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are the natural numbers. B, then you have the whole numbers. The whole numbers. And they are, symbol is W. The whole numbers are real close to the natural numbers. The only difference is they include the whole, the 0. So they are 0, 1, 2, 3, dot, dot, dot. The whole numbers. We're getting a little larger, okay? There's one more member in the whole numbers than in the natural numbers, and that's the member of 0. Then from there you go to integers. Integers. Integers are Z. Z is the symbol for integers. Now we add all the negative numbers. So dot, dot, dot. We're going to go -3, comma, -2, comma, -1, comma, 0, comma, 1, comma, 2, dot, dot, dot. So notice now we have taken the whole numbers 0, 1, 2, 3, and up, and we've added to them all of the negative numbers there, the negative whole numbers per se. Okay? Those two together become the set called the integers. The integers. After that is a set called the rational numbers. The rational numbers, and their symbol is Q. Q. You say, why not R? Because our whole set is called the real numbers, and that's an R. So we're not using R for rational, because R is for real rational numbers. The best way to think of rational numbers is anything that can be a fraction. Anything that can be a fraction. And technically what we mean is a integer for a numerator and an integer for the denominator that gives the exact value of the number. Okay, so really what we've done is we've taken the integers because, for example, the integer of 2, can that be made a fraction? Well, absolutely. Isn't a 2 over 1, and that's a fraction, and that's fine. Or some people don't like to consider 1 as a possibility. So, and that's, I probably shouldn't. So really, how about like 4 over 2? All right, 4 over 2 is 2, isn't it? That's a fraction. That's good. So again, I really should not have considered 1 there, because then you can make anything a fraction. But 4 over 2 would be 2. You know, and you can do this with everything. No matter what there is, you can come up with an integer on the bottom that's not 1 that gives you the exact value. Those are fractions. You know, 3/4. All right, that's not an integer. So that's one of those in-between ones added for the rational numbers. Added for the rational numbers. Okay, so these are the number sets that we are talking about. Now there's also a set called the irrational numbers, and all these make up the real numbers, but Really, we're trying to learn the closure property right now, and we have to remember what our number properties are if we're going to understand the closure property. Okay, so let's give you an example of the closure property. For all, and I'm going to go to red here, integers. For all integers, so that's the set we're considering. Is there closure for, and I'm going to go in green here, addition? Is it closure for addition? So here's really what we mean in symbol form. No matter what integer a, if you add it to another integer b, in other words, we're adding up two integers. Here's the point. No matter what two integers we add, will we always get an integer? Do we always get an integer no matter what two integers we add? And the answer is yes. No matter what two integers you add, you are always going to get an integer. For example, and again, if you can find one thing that doesn't work, then it's not closure. It has to work for every single possibility. But for example, 7 plus 3. Does the answer give you an integer? Is 10 an integer? Yes. Okay, it works. You can do this. How about negative 9 plus 2? Both integers, right? Negative 9 is an integer, 2 is an integer. What do you get when you add them up? Negative 7 is negative 7 an integer? Yes, it is. Okay, it works. Okay, that's closure. Let me give you a counter example. Here's something that does not work. So let me give you one that does not work. So example, and we'll stick, let's go with for all whole numbers. Okay, so that's the set we're talking about, whole numbers. Is there closure for, and now we're going to go subtraction. Is there closure for subtraction? So what are we asking? What are we trying to figure out? We're going to take the same situation. We're going to take any two numbers, and every time we should end up with a whole number. No matter what two integers, or I'm sorry, what two whole numbers you subtract, do you always get another whole number? Now remember, if you can find one situation where it does not work, then you don't have closure. So, I can find a ton of situations where it will work. Here's one where it will work. If A were 10 and B were 5, those are both whole numbers, aren't they? They are. What happens when you subtract them? You get the number 5. Is 5 a whole number? Yes. It worked. But here's the problem, and here's the thing with closure. If you can find just one thing that doesn't work, then it's not closure. So let's flip the numbers. What if we put the 5 first and the 10 second? Both whole numbers, right? 5's a whole number, 10's a whole number. What's the solution? 5 positives, right? And 10 negatives leaves you 5 negatives. Is negative 5 a whole number? And the answer is no, this is not a whole number. So that implies not closed. There's no closure for the whole numbers for subtraction. So that's the concept there, and you can do it with all the different sets. Closure. All right. Understandably, I know that one's a little bit odd, and you might be saying, oh no, these are going to be hard. That closure's a little bit difficult. The rest of them are pretty easy. So number 2. Number 2, and I'm going to go to red, commutative property. The commutative property, C-O-M-M-U-T-A-T-I-V-E, the commutative property. The commutative property. The commutative property. Now, there's a lot of different ways you can term this. But basically, let me try to boil it down to the basic understanding of the property. And it's basically this. When adding, because we're talking about properties of addition, when adding the, and I'm going to go to the red here, this is the key, the order. When adding the order, and I'll finish off in blue, can be changed. When adding the order can be changed. That's the commutative property. When adding the order can be changed. Now we know this to be true, and we've seen this to be true in many situations, but this property allows us to do this with not only numbers but variables and other situations. It's telling us that we can change the order, and it will be true. For example, we all know that 3 plus 7 is 10, but according to this property, it will equal and should equal 7 plus 3. See how we changed the order? Here the 3 is first, right? And the 7 is second. Where here, now the 7 is first, right? And the 3 is second. We've changed the order. And so that's what the commutative property tells us we can do. It says when adding, you can change the order. So here's the property in variable form, and this is the way you should learn it. We'll use a little bit of color here. I'm going to use a red A, do my plus sign in blue, and then I'm going to go to green B. So we have A plus B. So again, because it says we can change the order, we'll put a equal sign, and now instead of the B being second, I'll put the B first, and instead of the A being first, I'll put the A second. We can change the order. That is the commutative property. When adding, the order can be changed. Okay? Now you have to do whatever you need to do to associate, to put together commutative and order. That's the key. Order can be changed with the commutative property. And so you have to do everything to make sure that you connect those two. Let me show you a practical application of this property. All right, so let's suppose we had a problem like this. Let's go 3 plus 8 plus 9 plus 7 plus 1. 3 plus 8 plus 9 plus 7 plus 1. Okay, now we could add that up, and it's not hard numbers. When the numbers are bigger, it would be a little bit more difficult. But look, if I wanted to, let's take that 7 here, and instead of having it way back there, let's put it second. Okay? So we put it second. Okay? Great. I'm going to leave that 8 off. Let's take the 9 now. Keep it third. It was third. We're going to keep it third. Let's take the 1. Here it was last. And let's stick that 1 fourth. Okay? And so now at the end we have an 8. Now look what I just did. 3 and 7 is 10. Very easy to deal with. 9 and 1 is 10, is very easy to deal with. And of course 10 and 10 is 20 plus 8, 28. And we can use the fact of the commutative property to rearrange our addition to make it easier to add the numbers. Okay? Now we'll talk about this a lot more, like I said, throughout our math. Pre-algebra, algebra 1, geometry in algebra 2. But it's the commutative property. The key word, again, is the word order, and you gotta keep that idea there. You gotta understand the word order, right? Order is the key. You gotta get that in your brain, commutative property and order. Okay, commutative property and order. Number 3. Number 3, the next one is the, and I'm going to go to green, associative property. A-S-S-O-C-I-A-T-I-V-E. A-S-S-O-C-I-A-T-I-V-E, the associative property. The associative property. Okay, think about someone's associates. What does it mean to be an associate? Well, it's their buds, right? It's their pals, it's their friends. It's those that are part of your group. That's the key to the associative property. So how does it go? when adding and then I'm going to go to green, grouping. When adding the grouping, and I'll finish off in blue, can be changed. When adding the grouping can be changed. That's the associative property. So for example, let's do some easy numbers. Let's do something like this. 3 plus 7 plus 2 equals, and let's go 3 plus 7 plus 2. Okay, 3 plus 7 plus 2 equals 3 plus 7 plus 2. We haven't changed any order, have we? No. And we shouldn't, because that's the commutative property. Let's now add parentheses to show grouping. Let's put a parentheses around the 7 plus the 2. See how the 7 and the 2 are grouped together? Okay. Now in the second part, across on the right hand side of the equal sign, let's group the 3 and the 7. So if you look here in the left hand side, the 7 is grouped with the 2, and here, oh, the 7 changed. 7, 2's out, forget you 2, we don't care about you anymore, I'm with 3 now. Alright, we changed our grouping. That's the associative property. And of course, mathematically it says it's going to be true, so let's try it out. We know that we're supposed to do everything inside of parentheses first. So when you add up what's in the parentheses, you get a 9, right? Now if I'm doing it on this side, I add what's in the parentheses and I get a 10. Oh, it's not going to work. But notice on the left, 3 plus 9 is 12, and notice on the right, 10 plus 2 is 12, and sure enough, the two sides are equal, and it did work. So we can change the grouping according to the associative property. So just like before, you should memorize the pattern with the variables, and that's what I'm going to write right now. So we'll do the same thing with our blue here. We're going to do A plus B. Notice I'm spacing them out enough to put parentheses in. Plus C equals A plus B plus C. No order has changed, but we're going to come in and group, in the first case, the B and the C. And then we're going to change the grouping to the A and the B. This is the associative property. And again, this is what you should memorize. So make sure you know the associative property. And again, what does it involve? It involves that we can change the grouping, right? The associative property, you can change the grouping. Okay, next one. Let's keep rolling along. Number 4. Number 4 is and I'm going to go to black here, identity property. The identity property. The identity property. All right, this is what I try to get students to remember with the identity property. I say back to the, and I'm going to finish in black, original. Back to the original. Okay, back to the original. Now this one is easier for me to show you in the variable form first. So let's take our black, let's do the letter A, and we're talking about addition, right? So in my blue, I'm going to do plus. So I'm going to take my red, and I'm going to put a 0. Now, what does A plus 0 equal? Well, hopefully you thought in your head A, and it does. 5 plus 0 equals 5, 8 plus 0 equals 8, 20 plus 0 equals 20, negative 2 plus 0 equals negative 2, a half plus 0 equals a half, A plus 0 equals A. This is the identity property. See how you're back to the original? Right? You're back to the original. We started with an A, we added something to it, 0, and we ended up at A. You're back to the original. That's the identity property. Now, we have a term also associated with the identity property. And there's a number that's called the identity element of addition. And we're going to write that out. The identity element of addition. a lot of words, isn't it? The identity element of addition. And what the identity element of addition means is, what can you add to something to get it back to the original? That's the identity element. So the identity element for addition is the 0, right? 0 is what you can add to something to get it back to the original. And look, this is going to be true no matter what the situation. With numbers, it's easy to see, right? Again, we know 8 plus 0 is 8. But look, we can also deal with variables. 3n plus 0 has to be 3n. This is basis of the kinds of things we're going to do to solve equations later on. We'll use these properties and apply them. Okay, you can have something even more complex. How about a negative 2x cubed divided by y plus 0? Well, you know what that's going to equal? A negative 2x cubed divided by y. In each of these cases, we are back to the original, back to the original, back to the original, right? We are back to the original. So again, what you have to put together is the word identity, right? The word identity and the word back to the original. The identity gets you back to the original, and that's what you got to remember. That's why in pre-algebra you got to study, because you have to remember that. I don't think that's hard to see, and I don't think it's hard to understand, but you have to remember it. You have to remember it. Okay, we have one more, and we're done. Number 5. Last one, and I'm out of colors, so we're going to do this one in blue, and that's the inverse property. The inverse property. The inverse property. Okay. Now, let me let you in on a clue. In a couple, down the road, couple lessons down the road, we're going to do all these properties in multiplication. We are. All right, so just listen for a second. Let me go back for a minute here. We're going to do all these properties in multiplication. And guess what? The commutative property is going to be just the same. When you're multiplying, you can change the order. That's what's going to happen in multiplication. And you know what? With the associative property, when multiplying, you can change the grouping. And with the identity property, when multiplying, you'll get back to the original. Back to the original. They won't change. The only one that's a little different is the inverse property. And it's a little different in addition or subtraction. The inverse property tells you to add, and then I'm going to go to red, opposites. Add opposites. Add opposites. Okay. Now, we've already talked about opposites. Opposites are two numbers that equal 0, right? Remember that? You don't need to write this, right? Two numbers that add up to 0. 5 and negative 5 are opposites. Negative 3 and 3 are opposites, right? Two numbers that add up to 0. So the inverse property involves adding opposites. That's what it involves, okay? So if we were to do it with numbers, it would look like this. Let's take the number negative 7, right? And we're doing the inverse property of addition. So what do we add to it? We need to add its opposite. So what is the opposite of negative 7? And that's 7, right? In this situation, we end up with 0. Okay? We end up with 0. So we are adding opposites. Adding opposites. Now, there's also another term. Not only are our negative 7 and 7 opposite numbers, they're also called additive inverses. Additive inverses, hence the name inverse property. And the opposite numbers are also called additive inverses, so you have to be prepared for that and expect that to pop up. Additive inverses. Okay, so how would we write this property? Well, we're going to start with the letter A, and we have to add to it its opposite. And what is the opposite of A? It is a negative A. right? Remember, opposite numbers, the same value, one positive, one negative. The fact that they're both A make them the same value. One of them is positive, one of them is negative. And you know what? We know by the inverse property that the value of those two is 0. Okay, the inverse property, add opposites and you get 0. So again, you have to associate, you have to put together the idea of the inverse property with the idea of add opposites. But please, in all of these, make sure you learn the variable idea of the property. All right, that stretches right out of our screen, and you can't even see it there, but that's what you got to center on. Okay, so these are properties. These are things that anyone can learn. Can be a little tricky, but if you'll remember the key words, so let me recap one more time. Commutative property, what do you got to watch? You got to watch for the order, right? Commutative says you can change the order. And again, this is what you're going to work on, right? A plus B equals B plus A. That's the variable form. We change the order. Associative property, what are we going to do there? Associative says we can change the grouping, right? Associative says we can change the grouping. I guess I didn't write a very nice oval there. All right, let me get back to that. Right? Associative, we can change the grouping. And again, the variable form of that is right there. Notice that the grouping changed. And so those are the things you should be remembering. Identity property, we're back to the original, and again, the boxed in property is the property you want to learn, back to the original. And then finally, the inverse property. With that, you've got to add opposites. That's what you want to remember there to recognize the inverse property. And oh, I see I did not box it in. So let me box in the inverse property down here, because again, that is what you want to learn, the inverse property in variable form. Okay, that is lesson 2.1. I hope you guys have a great night. The good thing is, tomorrow in class, you'll get to work on your homework, and hopefully you'll get it done in class, and if so, you won't have any homework then tomorrow night. Have a great night. Thanks for listening. Bye now.